Friends, Gujarat Technological University has been engaged in developing entrepreneurship amongst our students. The idea is that the students should be able to not only understand engineering concepts and become better engineers, they should also understand that the products are designed for a particular market, for a particular user, and therefore we should start developing a user-centric viewpoint. We are therefore thinking that entrepreneurship is a very important part of the total study. One, when you start thinking about a new product, you start becoming innovative. You start looking at what the rest of the world is doing, and then you will not start studying things which are outdated and which are not really appropriate. Secondly, as an entrepreneur, you will develop your own skill set. You will know when you start developing a product that a lot of interdisciplinary inputs are required. You will know what it takes to develop a product, to design a product, to make it. And then you will start developing your own skill set. We are talking about skilling India. We have also to see that our engineering students, when they graduate out, have a good set of skills. But then, unless we motivate them, they will study something in the class, appear in the exam, pass, but at the end will have no skills. Because you cannot impart skills to a person who is not really motivated himself or herself to learn. Therefore, the idea of skilling India is a great idea. That's the only way India is going to go forward. But then we at Gujarat Technological University feel that while skilling the uneducated, skilling the young who are not having any other way of going ahead is very important. Making our engineers acquire a good set of skills is even more important, and that is our job. So therefore, thinking about entrepreneurship helps them develop that particular idea also. Lastly, we have seen that when you start learning about IPR, when you start learning about the patents in your own field, you start becoming aware where the world is going. If you do not have a look at that particular part, if that is completely blank by the time you graduate out, then probably you will go on becoming comfortable with age-old technologies. And therefore, it is very important that a student should be aware of all these issues. And these issues ultimately are tied up with understanding the ideas of entrepreneurship. More importantly, we have tried to develop the whole concept in a holistic manner. We have tried to include, while studying entrepreneurship ideas, things which are an integral part of our pedagogical system. For example, when a student starts developing a project, he should have first of all a clear idea about how the project is to be designed. The design process has been systematized by many universities, and luckily under Stanford University MOOC program, courses are available which you can take in just $5. So you can go to the Stanford site and understand what design is. That is the way design thinking has evolved today. We cannot continue to go on using the outmoded methods. Of course, the engineering design that we do in electronics or in mechanical engineering or in civil engineering, that is required. But the fact is that if you do not study the today's methodology, probably you will go on designing products which are not competitive in the market. You will go on designing products which are not as good as required, because with new technology, with new materials, with new methods of design, the products which come out are today much superior and aesthetically much better than the products used to be, let's say, even 10 years back. And we have to understand that particular idea. Of course, whatever we have learned in basics of engineering is not going to change. But then we are always not only going to construct the foundation, we are also going to put up a building. So foundation is important, and many of the ideas, foundational ideas probably will not change, or they will change rather slowly. But the fact is that both the foundation and the superstructure have changed over the years. In fact, even the foundational ideas have not remained static. And we will not get into these things unless we start looking at what the rest of the world is doing. In fact, unless we start looking at the products that we are using, unless we start looking at the buildings that we are working in. Because today, many of our buildings are also not designed by us, they are designed by others and of course implemented by us. So we have to understand the new materials, the new ways of designing, and that's what this particular program is supposed to do. The inputs which are required for a young engineer are pedagogical inputs in the classroom, in the laboratories, in the workshops, but there are also inputs which are required from the society. For example, at Waterloo they conducted a survey and found that Waterloo is considered to be the hub of innovation, where companies from all over the world have flocked, and right on the campus of the university, companies have put up multi-story research buildings where they come and do research along with the students and the teachers. You have IBM there, you have Microsoft, you have Google. They are all sitting right on the campus of Waterloo. And a detailed study in Waterloo environment proved that entrepreneurship has succeeded in Waterloo only because there are success stories which are available. Historically, they have developed how the success stories developed, and I do not want to take your time to repeat what has been studied over there. What I want to say is inputs from friends, inputs from family, they are also very important. And of course, input from extracurricular resources. An engineering college is not a separate institution where you just take some textbooks and teach, where you just go to the labs and workshops and do that prescribed work. You have in engineering colleges technology clubs. In every engineering college today, you have, for example, a club which makes games. Making a computer game is not so easy. You have to learn a lot more of computer science than you will learn in the classroom. Similarly, we have open source technology clubs, we have mobile and wireless technology clubs. These are all very important. For example, the wireless technology that you are using every day just didn't exist 20 years back. Nobody knew how to make this kind of small mobile phone. So these are all technologies which have been developed. And we may say, well, we are teaching design of electronic circuits for 20 years. That's okay. But then I'm not saying that particular design is not required. But if we are going to teach only that design, then we will design products which will be of no use to the whole of the world. And will be of no use, in fact, even in Ahmedabad. So therefore, in every field it is happening that we have to develop new ideas, and we have to therefore have this kind of technology clubs. All over the world, professional societies have their offices right on the campus of engineering colleges and universities. For example, you have IEEE, you have Association of Civil Engineers, American Association of Civil Engineers. So similarly, we have our Institution of Engineers or Computer Society of India. These institutions have got to be nurtured and developed right in the technological universities. We have somehow pulled ourselves out of it. Those are places where the students and the professors and of course the professionals work together. And what has happened is many of these institutions have become totally professional clubs from which all academic institutions are excluded, or you can say we have excluded ourselves. These are inputs which are as important as the inputs we give in the classrooms. These are inputs which are as important as the inputs we get in the workshops and in the laboratories. But we have somehow opted out of these. These have to be brought in and made an important part of our learning process. Then only we will be able to stand tall and say, well, when I graduate from GTU, I will be as good an engineer as an engineer from any university in the world. That's what we have to aim at. And the whole program of GTU is a holistic program. Our syllabi, our work in the classrooms, our work in the laboratories, our work in the workshops, our work in entrepreneurship, our work in the process of permeating the design thinking right into the whole of the syllabus, our process of trying to design laboratory work in such a way that all the parameters are not completely fixed and the laboratory work does not become an exercise in drawing graphs only. Our process of adding a strong design spine into the whole of the program is already well appreciated everywhere. In fact, we started creating our new syllabus with design orientation and project-based learning in 2012. From August 2013, we have implemented it. And interestingly, in January 2014, at a retreat of all the IITs and of Bell and all the great Indian companies of Government of India, all the managing directors of these companies, all the IIT directors, they went on a retreat for 3 days and sat down and thought how engineering can be rejuvenated, engineering education can be rejuvenated. And you know what the decision was in January 2014? It was that we should introduce design orientation into the engineering syllabus. There is an institute, Advanced Institute of Information Technology in Japan. They thought that they must change the way of engineering teaching. Therefore, they started talking about project-based learning. Now, project-based learning in IT is nothing but design-oriented learning in the rest of engineering. So, that's what they started talking about. And then they persuaded the entire Asia Pacific to come together. So, therefore, an Asia Pacific engineering network was created with headquarters in Jakarta. And what is APEN doing? APEN is doing the job of ensuring that engineering education in East Asia is design based, that engineering education in East Asia is project based. That's what the charter of APEN is. And APEN has been doing this job for many years. Now, of course, this year, APEN people came to India. They saw that GTU is doing something, and therefore, they have asked us to be the director on APEN for India. We have not yet started doing much of a work. They just came and signed an MOU with us. Hopefully, we will also get inputs from them and we'll learn from what they have been doing over the last few years. In France, there is a new kind of engineering college. An engineering college where there are no classes. Of course, that is only for IT. That particular college is only for IT. In that college, when a student joins on the first day, he is told, well, this is the problem you have to solve. So they just give him a problem, a project to do. When he does it, how he does it, is entirely his job. And normally students work there in groups. Sometimes they work at night, sometimes they work in the afternoon. It is their job to get the information, but they have to solve the problem within a particular period of time. And once they solve it, they get the next problem. The whole of 4 years is used only for solving problems. All the 4 years are used for developing projects. And once they have developed a particular number of projects, well, they get a degree. A new kind of engineering college, which has no classes, which has no specific teachers. There are teachers sitting there for consultation. Go to them and ask them and learn from them if you want. If you don't want, learn yourself. So that's the way that college is. And today, people have poured millions of dollars into that particular college. And as soon as those students pass out, they are recruited by the topmost companies of the world. That's where engineering education is going. And if we will go on sitting tight here and saying, well, our old methods of teaching are so great. Yes, we should not forget old methods of learning. For example, During the Greek times, people used to learn geometry, and we are also learning geometry today. But whatever geometry existed in Greek times, that we study today in 8th or 9th or 10th standard. What you can study in geometry at college, at the university, in PhD, that is much more, something which did not exist at that time. And a prince wanted to learn about geometry. He went to an academy and he was told, well, since you are going to become a prince, you want to learn geometry so quickly in 1 or 2 years. It's not possible. It takes a lifetime. Yes, it takes a lifetime even today to learn geometry. But today, what was taking a lifetime 2000 years back is done by 9th or 10th standard. Over 2000 years, things have changed slowly. We have got printing, we have got other technologies. Therefore, what the Greek used to take a lifetime for learning in geometry, we are learning it up to 10th standard. Similarly, when the world is going ahead, they are going to learn much more in 4 years than we will, unless we change our ways of learning, unless we change our ways of technology use. Therefore, let's not go on sleeping and say, well, our old methods of learning are great. I am not saying they are not good, but we have to every day improve them. We have to every day improve our learning processes. And the process of entrepreneurship learning in our campuses is meant to do that. There is just one point more I want to make. The entire effort of Government of India, of all the policy makers in entrepreneurship, has been devoted to developing policies for NITs and IITs and single campus universities. They have never worried about handling what is required at affiliating type universities like ours. And it so happens that more than 95% of engineering students in our kind of universities, probably some 3 or 4% students are covered by all the IITs and all the NITs and all the deemed universities put together. And if a policy touches only those 4 or 5%, then what good is of that? What good that policy is going to do for the country? We at GTU have been developing policies which impact every single college here. We think if we succeed in creating this hub and spoke model, we will develop something which will suit the system in India. There is no way India is going to be able to make the kind of investment required for creating one Harvard. And there is no way this country is going to be able to create 20 Harvards. We will have to create our own system. And still we will have to come up and compete with the world. I think you require a set of policies which can work with affiliating type universities. Then only we will work. Let's not be afraid of large systems. Let's not say because England does not have large universities, so why we should have. Well, they don't have because their population is less. They don't have because their history is different. We have because we have a different history. And there is no need to say our systems can never be as good as theirs. Ours can be better. Only thing is we have to work hard, develop our own systems, develop our own policies for affiliating type universities. After working for 4 years at affiliating type universities, I can tell you, affiliating type universities can do much more than a single campus university. At least the experience of GTU proves that we are no worse than any other similarly situated university in India. And in fact, we are much better. It is because of the policies that we have been following. And I think similar policies, extension of these policies at the state and the central level may help the nation much more than the policies we have been following earlier for the last 60 years, which have been great, which have brought us up to this point, but we'll have to do something much different. Thank you.